looking for questions that are potentially challenging, or just letting our interests guide us. So this is just it's a way to study and learn, and that's it. So, okay, this is very easy. Okay, don't anticipate any problems. Okay. Just plug it in. Okay, basic multiplication. Okay, basic logic. Okay, just reading the graph. Also, yeah, like you can see that so very important to actually read the question, right? So how much more did he deposit? Not how much did he deposit? So we see a pretty clear slope, like he's depositing 100 a week. But then it's about how much more, and it looks like Jeremy is putting in 50 a week, right? 6 weeks, so 50. All right, easy. Function h5 h3. Cool. 2 to the 5th. It's 32, right? I'd like to have those more memorized, right? 2 to the first is 2. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. Okay, so 32 minus 8. Okay. Very cool. Nice. Oh, so the margin of error. So it was plausible. Okay, so this isn't their confidence rate. It's unlikely. Okay, let's do it. So I'm gonna. All students. Okay, so actually it is likely, it is potentially likely, because the margin of error for the estimate is 4%. So like it could be 22% or whatever. At least 23% no, because it goes up and down. It's not this sure as plausible that the students is even at least once per month is between. Yeah, I think that's that. Well, it's interesting how they present it, like that margin of error goes both ways. I don't remember doing this problem. But so I'm going to go with D. I hope I'm right, actually. I might have to check my answers. Okay, it's straightforward. Straightforward. reading graphs. Right circular cone. Right circular cone. Do I know the equation? 1/3 pi r squared h. One-third pi r squared h. Okay, we have the volume. Alright, whatever. I wanted to scroll through, but 1/3 pi r squared h equals 24. Looks like I'd have to write this down. Okay, this is too straightforward. Whatever. Straightforward. Huh, what is this printing? We're missing the line. That's surprising. It's a misprint. Radius. Alright, so we're just like moving it around. So let's do v over pi. Let's do 3/4. And okay, so yeah, fine. D. Based on the table, this one goes always given that they didn't enter never. Okay, so 30.9 over 30.9 plus this. Okay. Okay, so it's downward facing. It's downward facing. Oh yeah, we could use a graphing calculator. So that's going to be interesting actually, because the graphing calculator, I guess the interesting thing about this A thing is it doesn't matter. Because we're not talking about anything other than like the min and max. So that's interesting, right? So if we know it's downward facing, then we know that we're going to be looking at a maximum yeah, so maximum makes sense because 0 is like the most positive we can get from this. Because all other values are going to be negative and then bring it down. So D, okay. Including in the original. I would say including with the original instead of in. This following measures must be 12 greater. Oh, okay. The rain. That was a max. Okay, just got a little distracted. Just thinking about some travel ideas. We go to Amsterdam, Holland, the family. Okay, so mix this. Straightforward. Doubling. For each, she doubled the amount previously. Is this exponential? Yeah, because it's the amount previously. Yeah. And we could look at it, right? So 30, 60, 120. That's not a line, right? So it's a nice thing, words, like a lot of this, it's about reading and it's like pay attention, right? Linear function, a line, right? Understanding there's a difference between a line and a curve, right? You cannot draw a line between 30, 60, 120, 240, right? This one's kind of cool. Just like looking what's going on, right? So over 2, down 1, over 2, down 1. So, also, again, understanding input output, we talked about in the previous video. So the equation has to work, right? So in terms of like a method we could use, and in terms of doing that quickly, if we have a 0 option, that can be like a quick identifier. Actually, so here we know that when y is 0, x is supposed to be a. So it works for a, right? Because if y is 0, then x equals a. But here it doesn't work. Here it doesn't work. And here it doesn't work. So actually we can just say it's a. And then I think it's worthwhile to confirm just because maybe we made some mistake. And if a is correct, then it'll work for these other ones. So that if x is 3a, okay, so 3a plus 2 times negative a equals a. So that works. And then I won't even do a last one. Okay, so we've confirmed it. That's good. Following from the equation. Okay, basically just reading that. I think I've seen people make mistake. Oh, is that true? Did they? Maybe not. It's been a while. But, or it's just, I guess it's not necessarily relevant. It is relevant to know to scale, I guess, either way, potentially, because this is moving over 20 for each box, but it's up 10. So, so that's important for, okay. These I find very easy. The x-coordinate of the intersection. Okay, that's kind of an interesting structure. The x-coordinate of the intersection point of the system. So we want the x that's going to give us the same y. And okay, so I can multiply this one by -3. So then we have a negative 1.5y. Or would it be better to let's actually do this one instead. Let's multiply it by 5. So we're going to multiply both of these by 5. And that'll give us the answer. So that's fine. And again, it's like one of the easy ones where you can check it, like you see if it makes sense, then it makes sense. Okay, we've got one. Okay, whatever. Oh, interesting. Okay. So, again, understanding upward facing, downward facing, right? So it's upward facing. And then what are the differences? Is we have left side versus right side. So what makes it start on the left or the right? If you have, move it over. Yeah, so this is something to improve on a bit for me, apparently. Now, on the test, what I can do very simply is just take a graphing calculator and just plug in some values and then just see. And we're going to see that, one's going to be starting on this side. And this is kind of, I don't know, it's maybe a little embarrassing, I guess, that my fluency is not there or that I'm not instantly getting it or something. But the thing is with this experience also is that it's just like, it's just good to learn. And so it's like, okay, yeah, I didn't get it instantly. Now I'm going to learn it and then I'll probably remember it and then I'll get it next time. So what puts the, oh, okay. So actually, yeah, it's quite simple, right? So basically, let's think about it, right? So where's the vertex? The vertex is between the two roots, and the since it's between the two roots. Oh, interesting, right? Oh, this is also interesting, right? So in one of the roots, right? So again, like the thing is like develop it like fluency, like understand like the full picture, right? So the full picture here is that one of the roots is -3, right? Because -3 makes this 0. So, and that's another way that we can cross things off because this is going to -2. It has to go to -3. And actually here also, -2. This goes to -3. So maybe this thing actually was not, what I was talking about, that's actually not the point because it depends on how far forward. I mean, it is sort of the point, I guess, right? Because if one of the roots at -3, and then, the farther we go to the right, then the more the vertex is going to go to the right. with the other root, because it just has to be halfway in between. And so this is just wrong because of that. Interesting, right? Because the k, yeah, and that's also just remembering. This is like really simple, right? Just remembering that like the root is the opposite of the. I don't know if is opposite the right word. Like it's -3, the opposite of 3, or whatever. The root is the the constant times -1, right? So okay, so this is good. I mean, this is like really the type of result and the refresher that we really want to get, and beyond. Just like, remember, okay, what is this? These are the two roots, in terms of what's it going to look like on the graph. This is going to look like, -3. This is going to look like positive k. And since the x's are both positive, then we're going to be upward facing, and then there you go. Okay, whatever. Quadrilateral. AD is parallel to BC. CD is half of AB. Does that tell us something? 2x. So, I mean, it's pretty clear we're doing like 30, 60, 90. Apparently I need to just refresh my special triangles. Is it x, 2x, and x root 3 or something? What was it? Okay. Okay, right. So that's what we're working with. X, 2x, 3. And so then we have 60 plus 90. So we have 150, yeah. So just 150. Also, if they don't tell us that it's not the scale, then it is the scale. So it's like we can cross that off. Yeah, all right. Wow. Okay, straightforward. Okay. So the little technique here is that if the mean is 1600, then we can basically like remove things that are 1600. So like this number is irrelevant. I can add 1200 to 2000 to make 3200. So the average of these three numbers is 1600. And so now I have two more numbers, and I need them to also average to 1600. So then this is 900 less than 1600, and so we need to like make up for that. So then it's 2500. But also, we could just do, if the mean is 1600, then the total of all 5 combined is going to be 5 times 1600, which is 8,000. So then 8,000 minus 2,000 is 6,000, minus 1,600 is 4,400, minus 1,200 is 3,200, minus 700 is 2,500. There we have the answer once again. Fantastic. Y equals mx, where m is a constant. Y is 17. So 17 equals ax. What is the value of y? Right. It's like y 17 when x is something. What happens when x is twice that much? Oh, really? That's sort of funny. See, they're having fun. Is there any way there could be smallware? No. Infinite many solutions. 2.5. Wait, does it have to be 2.5? Because I'm making it, like, I want to make it so it'll be 4x plus 10 equals 4x plus 10. I'm happy with that. As a quick answer, but yeah, I think that's necessary because I need to have like the same amount of x's, I think, on both sides. I don't know. I'm not going to think about that more for now, I guess. So this is like a funny way to just write, like where's the vertex, right? Intersects parabola at what point? Yeah, a bunch of ways to do that. Okay, basic math. Basic math. Okay, cool.